All right, good morning, everybody, or good afternoon, depending on what time of day you're seeing this video, or evening, whatever. But this is Mr. Mena here. Just want to go over a quick example of what solutions and mixtures are. I'm going to go ahead and start with mixtures. Okay. First of all, mixtures is just a combination of many things that you can put together. It could be a fruit salad, a taco salad, just a bowl with a bunch of stuff. Now, if you can see in my bowl right here, I went ahead and put some pinto beans, some pecans, some peanuts. I even put a few nails in here. Okay. So the way mixtures work is that when you can put them together, you can still separate them. And when you separate them, there's different ways of doing that. I mean, you can use your hands. Okay. You can use tweezers. Okay. You know, if you want to be able to pull out little things. Okay, especially if you dip them in water, which we'll look at here in a little bit. But the important thing to know about mixtures, just basically, guys, is that when I do separate them, they still maintain their physical properties. All right, when I pull out the pecan, it's still a pecan in its form. Okay, if I pull out the nail, now again, I could use my hands, or in some cases, all right, magnetically, okay, you can use a magnet to separate these things. Okay, now sometimes these mixtures, all right, there's other materials here that you can use to separate. You have a coffee filter, you have like a sifter to sieve, something like this. Sometimes they're round as well with a handle on it. Okay, and then sometimes you got like strainers. They got the holes at the bottom as such. Okay, usually you do this when you're making mac and cheese, or someone's making spaghetti at home. I mean, there's different ways. Now obviously these things won't necessarily work. Like I said, the only exception here is probably just tweezers. It may be a lot harder, probably, especially grabbing the little things. Otherwise your hands, or if things are magnetic, you can separate them. But the important thing is that they maintain their physical properties, whether you put them together or whether you separate them. Okay, so keep that in mind, and we'll look at more examples this week, next week on mixtures here. Now the other thing to remember here now is when we look at mixtures, okay, when we look at solutions, now solutions are special types of mixtures. It's still a mixture, but we call it a solution, right? So there's different things that we can look at. When we look at solutions, we're looking at two things: the solvent. A solvent is going to be the liquid. In most cases, it's probably going to be water. And then we look for the solute. Okay, now this could be salt, it could be sugar, it could be Kool-Aid, lemonade. I mean, there's various types, right? And we're going to look at even one with sand, but you'll see what I'm talking about here in terms of what is soluble, or what has solubility and what doesn't. All right, so I'm just going to pour a little bit of sand. Notice the water takes the shape of the container. Okay, it's a cylinder-like, and it's got a little extra width here on the top. Okay, water's always going to fit in terms of the shape of the container. Okay, well, it could be any type of container, but just something to keep in mind. So I'm just going to put a little bit of salt in here, not too much. Okay, otherwise it's just gonna. Otherwise, if I put too much, it won't necessarily dissolve. Now, solubility is based on the ability for the solute to dissolve. Right now, I'm mixing it and I'm taking my time here. I want to really mix it in pretty good. Now, if you notice here, it looks a little cloudy. Okay. Now, is every little piece of particle going to dissolve? Probably not. Okay. Now, over time, what will happen is it'll probably eventually settle to the bottom. But you do have some little form of what looks like invisibility here. So this solution right here is what we call it a solution. It is soluble. Okay, that means it mixes with the water, if you will, and it's able to kind of dissolve. Now, how do we separate it? Okay, that's one of the biggest things. What do we do? Now, could I use a coffee filter? I don't know, maybe. Okay. But if I pour it down, and let's say I should have had a cup. Well, let me use this right here. Okay. Now, if I use this and I pour some of it down, am I going to keep all the salt here to separate it? No, And that's the thing with solutions. Sometimes they can be kind of tricky in terms of how we we separate the solute from the solvent. So, I mean, coffee filter, unlikely. We might get a little bit, but probably not. Some particles might go through, okay? Certainly not going to use tweezers to get the salt out. That ain't going to work. A sift, nah, unlikely, okay? It's not going to work probably because the salt's just going to go through those little holes right there. I don't know if you can see them. Yeah, so this ain't going to work, all right? Could this work? No, probably not, you know? So, you know, that's not going to work. So what are we only left with, all right? So if you think about it, how can I separate the salt, or even, like I said, if I had sugar, if I had Kool-Aid or lemonade, how can I separate the solutes from in there? In other words, the chemicals that I put in here. You think about it for a second, okay? Don't drink it, okay? That's one thing, don't do it. Or else you're gonna just keep that salt. Otherwise, the best thing that you can do is what? Now, think about it. We looked at the glass when we were outside when we did our experiment on states of matter, solids, liquids, and gas. What happens over time with heat, right? If heat, the temperature rises, the water's going to evaporate. So guess what? Our fastest way to probably do it is to boil it, okay? If I put this under like a heating pad or a pan or something like that, or if I poured it all in a pot, what's gonna happen? I heat it. What's going to happen though? It starts to bubble, right? It starts to boil. You see all the bubbles, and usually at about, I think it's 212 degrees. I could be wrong. It starts to come out, and over time, once it's all out, guess what? All that salt that I put in here is going to be left at the bottom of that pan or this glass, depending what I'm heating it with. Okay, so that's how you're going to separate things that you mix in with water. You're going to boil it so the water evaporates, and it'll still keep all of the same amount of volume of salt or whatever solute you were putting into it. Okay. Now some things are not. Some things are not soluble in water, right? So guess what? I got a little bit of sand right here. And some rocks. All right. Well, that's enough, I think. Guess what? It's got, I get this from dirt, so it's going to have all kinds of debris and different particles of leaves and stuff like that. Anyway, so I mix it up, and guess what? As you see it, notice it's very cloudy. It's very dirty, okay? So what's going to happen right here? How can I get rid of this water? Again, I can probably use a tweezer to get a little piece of leaf out. It's going to be kind of hard, all right? Could I use, maybe a strainer? Okay, this is a strainer, all right? There's different kinds of strainers too, by the way. Not all of them look like this. There's all kinds. Not all of them have handles either. So could I use a strainer? Okay, I might get some of like the big rocks that went in and they'll stay in here if I pour it. Okay, that might work. I don't know. Because usually the strainers have bigger holes. The sifts, when you go sieving, have smaller holes. You usually use this for baking powder. Now, if I put it in here, okay, let's put a little bit. Let's see what happens here. All right. Now, if you notice right here, I don't know if you can. Let me hold this closer to the camera. I'm not getting this too wet. I was able to get a few little pieces of debris in there from just using the sift or the sieving, right? And again, like if I had poured the whole thing, I'd probably get rocks, but would some of the dirt go through? That's the thing, right? So yeah, I mean, this could work too as well, but guess what? Again, we go back to our example, all right? Notice it's also settling at the bottom there. All right, looks nasty. Okay, and again, I could probably use a coffee filter as well. I mean, the water will go through, and I could probably get a good amount of sand on here. Okay, so this could work also as well. But ultimately, when we're looking at it again, you could always boil the water. It all evaporates, and then I'll keep all the properties. All right. So there's just different types of filtrations that we'll look at here in the next couple of weeks. Different things. You'll look at different videos just so you can just see a bunch of examples, okay? And again, if you're gonna try this stuff at home, please ask your parents' permission for it and go ahead and experiment away. Other than that, that's just a little brief introduction into solutions and mixtures. And if I forget anything, I'll be sure to cover it more so in class. Other than that, you guys have a good day. I'll talk to you later. Bye. Ew. All right. I don't want to drink that.